Hi, this is Real World Audio. This is János, and I have posted a video on the Quicksilver Mono, the original first incarnation of the Quicksilver Mono series. That's where it all started, and Frank has shared a lot of treasure about it and what's going on with that amplifier, and not just that amplifier, but he has a lot of excellent advice for push-pull amplifiers, and I just decided to just go through his posts because it's super valuable, and this will be very useful for those of you who own push-pull vacuum tube amplifiers, and also for those of you who want to build them or thinking about how to maintain them, and some considerations. So let's get into it. So on the Quicksilvers, originally the bias was measured with a jack plug on the chassis, and there was one bias trim pot and one needed to insert the plug in the jack plug and measure the milliamperes, not the voltage. So what's going on? With most amplifiers, you actually, I would say almost every amplifier that you can buy, you can measure the bias, and you need to set the bias to operate them perfectly, I mean optimally. And that's true for every single fixed bias amplifier. And that's really crucial, and I'm not going into why that's needed, but it is needed. But in most cases, there is a simpler measurement system, and you are reading the voltage, and the manufacturer specifies you what is the voltage that you want to read, and then you set it. However, here we are measuring actually the current, which is a much, I would say, a much more useful measurement for a vacuum tube, to know what is the current your vacuum tube is running at, because the higher the current it runs, the bigger the demand on the power supply, and also your tube will last much shorter. So for example, this Quicksilver amplifier was factory set to 120 milliamps, and it means that 60 milliamp per tube. And there was the measurement was to measure the actual milliamps. So with the bias, you could set the current consumption of the tube. And what is this measurement system that you could use? Here it is. I'm showing it to you guys. Maybe we can't see it. I think I would need a flashlight for that, but you know what, I'm going to move the camera over to my bench, and there are flashlights. So this is a meter, and it has a jack plug, so you plugged it in and it showed you the milliamps. And so that was the original measurement for to set the bias, and then with the pot you could adjust the bias. But this is another reason for failure when tubes are going to wear out different. And so the problem is that if you have only one bias adjustment, so you have to adjust the bias for the pair of the tubes, so they together are running at 120 milliamps, but you don't know whether they are each 60 and they are balanced, or one is maybe at 70 and the other is at 50. That's still 120, and you think it's all right, but they are not all right, because one is working double overtime and the other is taking a stroll in the park. And as the tubes age, then they tend to age differently. So even if you bought them as a matched pair, initially they are matched, but as they age, there's the distance between them is going to be greater and greater. And the one that is failing, it's going to fail exponentially faster. So the weaker one, as it ages, it's going to be weaker and weaker and weaker. And when you want to keep the bias at 120 milliamps, so you are cranking it up, and the wick is just going to fail at one point. And eventually cause failure and burn out the transformer winding, and also likely blowing up the tube as it goes red plating. Yep, so that's what you can avoid if you have individual bias spots. So you can set the bias for each of the tubes, and then you will notice that if you need to set the bias really to the pot to a really extreme position for one of the tubes, that's an indicator that that tube needs changing. And also, if you have bias spots separately for each tube, then you do not need a matched set, because you can set the bias individually. So this is probably one of the best advice for any tube amplifier. If you have a common cathode bias or a common bias point for the pair of the tubes, then make sure that you can set it individually for each. So here we go. The grid resistor is often a problem with fixed bias, neglected by manufacturers of many tube amps with fixed bias. What is he talking about? The problem is that in fixed bias, when there's a big signal coming, then the tube wants to draw a lot of grid current. So it means that the grid starts to act as an electron source as well. So the plate is starting to draw electrons, not just from the cathode where it's supposed to draw the electrons from, but also from the grid. And if you have a very high value grid resistor, then it's unable to draw the electrons from your ground. So it will start stripping the electrons of the grid, and that's something really destructive for your power tube, and your tube will fail because of that. So why are manufacturers using high value resistors there? Because the higher the value, the easier it is to drive that tube. So here is our power tube. If it has a high value grid resistor there, then the driver tube will have a much better low frequency driving capability, but at the cost that the tube, the power tube, will have a nightmare when there's a big signal coming, because it cannot draw enough electrons. And due to the loudness wars and the power wars, because everyone is pushing wants to put a bigger watts number on their amplifier to be able to sell them. That's why they are using higher and higher value resistors on the grid to sell that amp, of making it capable for lower bass, higher power, and also early grave. So that's why it's a complex thing. And when you buy a commercial vacuum tube amplifier, it's a really good idea to give it to someone who really knows that stuff, and just have them rework it a little bit to make it safer and long lasting. Indeed, auto bias, which is a self-bias with resistor and a capacitor to prevent feedback and loss of power. So what is it to prevent feedback and loss of power? That's the duty of the capacitor. So the auto bias is when you don't use the fixed bias, but use a resistor to protect the cathode and limit the current. So that's how you get the grid voltage, in not from an external supply as for fixed bias. And there you need to add the capacitor across that grid, across that cathode resistor, and that prevents feedback and loss of power. And it's a good way to better protect the tubes, because when you have fixed bias, there is nothing at the cathode. So if there's an issue in the bias system, like for example, because of that high grid bias resistor, the grid is unable to draw that extra current, you have problems, it starts to run away, there's nothing to limit the cathode, and the tube will red plate and blow. But if you have a cathode resistor, and that's how you are getting the bias, then if you have a grid issue and the tube still cannot run away, because higher current will increase the voltage dropped over the cathode resistor, which will limit the current. So it will act as a protection. So that's why amplifiers with cathode resistors with self-bias do not produce those spectacular failures when your amp just blows up from unexpectedly. So that's just the exclusive domain of fixed bias amplifiers, I would say. And you can also do mixed bias. So it means that you have an auto bias plus an adjustable bias. So it means that you have partially, part of the bias is produced by that cathode resistor, and part of the bias by a fixed and adjustable bias. That's a nice thing. It also adds a little protection, but it also gives you a higher power than what is available with that supply voltage compared to using self-bias purely. And yes, Frank is again emphasizing bias adjustments should be individual. And why is that? That's because everyone is just obsessing way too much over a matched set of power tubes for amplifiers, because the matched set is matched only for the few tens of hours of its life, and then the tubes start to age differently. And even if you match both a perfect matched quad of vacuum tubes, 500 hours later they will be all over the board. And I can say that, for example, if you use NOS, new old stock US made tubes, they tend to age together extremely well. And if you use modern production tubes or Russian tubes or Chinese tubes, they age the F. They just like cat piss, dog piss, just like one. They will be so different from each other that you would never even guess that they were a matched quad to start with. It will be just kind of like a joke. They are so far apart from each other as one transistor from another. So what happened to the shared bias resistor? That's when you bias them together, and that works only when you have a match set throughout the life of the tubes and the equipment. And I think now we are getting really into the time frame, so I'm just going to skip over that part, but that's really important anyway and interesting. What do I want to share? Always use correctly matched pair or output tubes, and the problem with that is just not just in a tube tester, because when you match them in a tube tester, that matches them to the operating conditions of the tube tester, which is drastically different from what's happening in your amplifier. So maybe for a tube tester it's a perfectly matched set, but you plug it in your amplifier and oh, you notice that one is drawing 20% higher current than the other. So good luck. So anyway, if you keep everything matched, then you never lose with good tubes and components. So basically Frank is saying that if you have like high quality vacuum tubes, then they are going to stay matched and stay close to each other and age well together. So all of those good Western European made vacuum tubes like Siemens's, and if you look at the British tubes or Telefunken, going back to more German tubes, they will age very nicely, very well in comparison to current made tubes which age pretty badly. More excellent advice, and yep, it's very big difference. Use NOS. They just sound much better, and in this amplifier you are going to hear the difference between tube rolling really well. Thank you, Frank. And this is some really nice story that Frank is sharing about this exceptional vacuum tube. And last thing I want to touch base is that this Quicksilver amp was able to drive 2 ohm load, so it has a 2 ohm tap in it, and that's kind of the end to that story that tubes cannot drive high current loudspeakers. Yes, they can when they have the taps to drive them. So if you have a speaker that dips to 2 ohms, you can drive it with these quicksilvers, put them on the 2 ohm tap. And don't blame it on the tube technology that it's not suitable to drive those loudspeakers. It's not the tube, it's that the output transformer is not matched to that loudspeaker. So it is the essential of tube amplifiers that they have output transformers and they match the tube to your loudspeaker. And if your loudspeaker cannot be matched to your amplifier, then don't say that the tube amp has no bass, because that amp has bass, it's just not made for that loudspeaker. You are trying to put the wrong size shoe on it. If you want to put the right size, put that shoe on the right size fit, look for this Quicksilver amp that has a 2 ohm tap. Yeah, use this to drive those heavy loads. Or there are some Conrad Johnsons, they also have 2 ohm taps, and some audio research. And anyway, there's a lot of amps that have 2 ohm taps. Seek those out to drive really heavy current loudspeakers. So thank you, Frank, for these excellent shares. And for those of you who want to read Frank's posts, where are they? Where can you find them? Where they are? Where can I find them? I'm going up so many posts. It's on this video. Look, peek inside the first generation Quicksilver Mono. So this is the my video, and Frank's comment is there right here. So I recommend to read them, and there's even more that I should read because I need to catch up with the comments. Thank you, Frank. Thank you for everyone for watching. Bye bye.